We're going to take a look at combining both horizontal and vertical transformations. But before doing that, let's start by summarizing the transformations of functions we've already seen. And then, after we will focus on how to combine transformations, especially combining vertical and horizontal transformations. So just as a summary, if you were to graph y equals f of x and also graph y equals f of x plus c, the new graph, y equals f of x plus c, should be shifted up by c units. So take a look at y equals x squared as an example, y equals x squared versus y equals x squared plus 1. You can work out the t-chart of, a chart of xy values, and you'll see that for the same x coordinate, like 3 here, 3 there, y coordinate of 9 versus a y coordinate of 10. You just need to make the chart, right, and see the 0.39 versus the 0.310. So every point that you had before has the y coordinate one unit higher, so the whole picture should be shifted up by 1 unit. So here you'll even see the original parabola drawn in sort of a thin, and then more thick you'll see the shifted up version by 1 unit. Same thing, if we take a look at f of x versus f of x minus c, that should be a shift down by 1 unit. So you'll see a specific example done here with y equals x squared and y equals x squared minus 1. So you'll see that shift down by 1 unit. And specific values of y coordinates have been shown here. And so this one point that was 3, 9 has now its new location in the new graph is 3, 8. Okay, c times f of x vertically stretches by a factor of 2. Again, you see all the numbers. And then 1 over c times f of x should then be a vertical compression. If c times f of x is vertical expansion or stretching, then to undo that you'd have to divide by c instead of multiplying by c. Finally, y equals f of x versus y equals negative f of x. So vertically flips. So think of y equals x squared as our example. Y equals x squared, which has all positive y values, versus y equals negative x squared, where all the y values should be negative. So all the numbers in the second chart of x and y values are negative. So original parabola still shown thin, and then in thick you see the more the transformation of the upside down parabola. Okay, those are the vertical graph transformations. There are also horizontal graph transformations. It's actually going to be harder to see what goes on using y equals x squared for the horizontal graph transformations. It's actually a lot easier to spot what's happening by looking at a new graph. So we're going to look at y equals root x. I want this to be a very standard graph, one that you just know exactly what it looks like without doing this chart. Again, the chart here is meant so that we can compare it with this chart over here. So for what about f of x versus y equals f of x plus c? Notice the plus c's in parentheses. This should be a shift to the left by c units. So comparing in our example y equals root x versus y equals root x plus 3. So you'll see you can really check that the point 1 comma 2 is a point in the graph of y equals root x plus 3. Okay, so the point 4, 2 that you had before is now at 1 comma 2. So to achieve the same y value, instead of the x coordinate being 4, the x coordinate now has to be 1. Similarly, if you look at y equals f of x, say you just know the graph of some function, any function, not just necessarily this function, but whatever function you have, and then you want to look at the graph of y equals f of x minus c, then you have to shift to the right by c units. So in our example here we have y equals root x versus y equals root x minus 3, and you'll see that shift to the right by 3 units. If you really check, if you were to graph y equals root x minus 3 carefully, there would be the point 7 comma 2, and you can just check. Take 7 and 2 as x and y, plug it into this second equation, y equals root x minus 3, and you'll see that the point satisfies the equation. Let's also take a look at y equals f of x versus y equals f of c times x, and that's going to horizontally compress by a factor of c. So comparing y equals root x, for our example, y equals root x and y equals root 2x, there's again this standard graph, and then here the new x values are all cut in half. That's because you're going to take whatever x value you have and you're going to eventually multiply by 2 to have root 2x in order to get the same y value. Okay, then in the same way, instead of doing x times c, if you do x divided by c, so you have y equals f of x versus y equals f of 1 over c times x, then this should be a horizontal stretch by a factor of c. So for example, y equals root x versus y equals root a half x. the picture stretches out horizontally. So you kind of stretch out this way and that way. I guess there's nothing here in this picture. So the point 4,2, by stretching horizontally, is now at 8,2. So the x coordinate is twice as big, but still the same y coordinate, being 2. Okay, and then y equals f of x versus y equals f of negative x. This will be a horizontal flip. So the graph that we had here now is going to look like this. So look at this. I know this looks a little strange because of the minus sign in the radical, but that's why we're picking negative numbers for x. So if you take negative 9, you plug that in, you have negative sign, and then x itself is negative 9, so you have negative 9 inside the radical. So that'll be a positive 9 inside the radical, and that's where we get the number 3 here. So there's no funny business, there's no complex numbers going on. The original picture, which looked like this, ends up flipping horizontally to being a picture that looks like that.